Hey there. Hope everyone's hanging in there. Let's get into O-level chemistry. Lesson 2 is the mole, formulae and stoichiometry. The mole is the chemist's counting unit. 1 mole contains 6.02 times 10 to the power of 23 particles, Avogadro's constant. Amount of substance N links mass m and relative formula mass Mr by N equals m, all over Mr. If 8.0 g of oxygen gas O2 is taken, N equals 8.0, all over 32 equals 0.25 moles. Always state whether you mean atoms, molecules, or formula units. Ask whether electrons are transferred or shared. Transfer points to ionic, sharing points to covalent. That single question organizes most of bonding. Empirical formula shows the simplest whole number ratio of atoms, molecular formula gives the actual numbers. From combustion data, divide each element mass by its R, divide all by the smallest, and scale to integers. C2H4 and CH2 share the same empirical formula but different molecular formulae. Structural formula shows how atoms connect. Balanced equations conserve atoms. Coefficients give mole ratios. 2H2 plus O2-2H2O means 2 moles H2 reacts with 1 moles O2 to form 2 moles water. Convert given mass to moles, use ratio, convert back to mass or volume. 44GH2, 2 moles, oxygen needed equals 1 mol equals 32 G. Molar gas volume at room temperature and pressure, RTP, is about 24 dm cubed per mole. Volume V equals nx 24 dm cubed. 0.5 moles CO2 occupies 12 dm cubed at RTP. For solutions, concentration C in moles dm cubed relates moles N and volume V. N equals CXV with V in dm cubed. 0.1 moles dm cubed sodium chloride in 250 cm cubed, 0.25 dm cubed, contains 0.025 moles. Percentage yield compares actual product to theoretical maximum from stoichiometry. Yield equals actual, all over theoretical x 100%. Percentage purity applies when an impure sample is used. Only the pure mass enters mole calculations. Limiting reagent is the reactant used up first. Excess remains after reaction. Identify it by comparing mole ratios from the equation. Water of crystallization appears in hydrated salts such as CuSO4.5H2O. Heating to constant mass removes water. Mass loss gives moles of H2O lost. Combine mole ideas with units, G, moles, dm cubed, cm cubed, divide by 1000 for dm cubed. Show working with significant figures appropriate to data. Link stoichiometry to everyday quantities. The mass of 1 mole of a substance in grams numerically equals its Mr. Avogadro's constant connects the microscopic particle count to the macroscopic laboratory balance reading, which is why chemists prefer moles over counting individual atoms when scaling reactions from test tube to industrial plant. Write a balanced equation, convert all given quantities to moles, use mole ratio from coefficients, then convert to required unit. State limiting reagent when 2 reactants are given. Burning 12G carbon in excess O2, N times C equals 12, all over 12 equals 1 moles, C plus O2 CO2 gives 1 moles CO2 equals 44G theoretical product. Do not use unbalanced equations, forget to convert cm cubed to dm cubed, or confuse Mr with molar mass units. Practice. Calculate moles in 20 G of calcium, R equals 40. Answer, N equals 20, all over 40 equals 0.50 moles. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. What mass of CO2 forms when 6G carbon burns completely? C plus O2-CO2. Answer: N times C equals 0.5 moles, mass CO2 equals 0.5 x 44 equals 22 g. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Alright, that wraps up the mole, formulae and stoichiometry. Next lesson we'll move on to atoms, isotopes and electronic structure. Stay curious and see you in the next lesson.